All right, we are going to start the next section or the next special pattern in factoring called perfect squares. And I want to, sorry, I'm looking for scratch paper here. Let me just show you for a second or remind you what a perfect square looks like. So perfect square would be, say, 16, right? Because it has a square root. It has a square root of 4. And 25 is a perfect square because it has a square root of 5. And the reason 4 is a square root is because 4 squared equals 16, right? That just justifies why 4 is a square root. And the reason 5 is the square root is because 5 squared equals 25, right? Something times itself equals a number. This guy is the square root. Okay, so we'll come back to that in just a second. Now, I want to start with our little checklist here because we're going to keep building on it. So to factor, it's really important that for every factoring problem, you go back to step 1 and follow these steps in order. Step 1 is to factor out the GCF, if there is one. Step 2 is to look for a special pattern. And we only knew one up to this point, the difference of 2 squares. Okay, and now we're going to have a perfect square. You don't want to get these two mixed up, and that's the problem. It's easy to do. Now, one thing I should also mention, 3, well, let's just leave it there. I mean, you still want to, after this, you'll have you'll have at least one more special pattern, you'll have trial and error, but you always, another step down here is to make sure you factored a problem completely. That means just because you factored it doesn't mean it's done. Sometimes it factors twice, so another step would be to make sure your factoring is complete. All right. But basically that's what we have as of this point. I'm gonna do a little chart to compare the difference, sorry, my dog is snoring, difference of 2 squares and perfect squares. Okay, to show you how they're alike and how they're different. And then on the side, we're gonna have a factored row, and then I'm gonna skip a couple lines and an unfactored row. Okay, now I'm gonna put another squiggly line because we're gonna come back to that. Now let's go ahead and fill out the difference of 2 squares part. Factored, it looks like A plus B, A minus B, right? One's plus, one's minus. That's when it's factored out. When it's unfactored, it looks like a perfect square minus a perfect square, right? That's why it's called the difference of 2 squares. These are 2 squares and there's a minus between them, and minus means difference. Okay, now we're gonna come back and fill out the perfect square in just a minute. I'm gonna go down here. Perfect square pattern. It goes like this. If you have A plus B squared, let's say, then notice that this is something times itself, right? Just like 4 squared equals 16. 16 is a perfect square because I can write it as 4 squared. Well, a plus b squared is a perfect square because it's something squared, right? Something times itself. That's what squared means. Like 4 squared means 4 times 4. And a plus b squared means a plus b times a plus b. Okay, that's going to equal a plus b. I'm just going to stretch it out, right? This is kind of condensed. This would be expanded, but it's the same thing. Now, let's say we FOIL this out. So far, these are factored, right? They're in the parentheses, it's factored. If I FOIL this, I'm going to get a squared, and then I'll get ab and ab. The outer will be ab, the inner will be ba, but that's ab. So outer is ab, inner is ab. If I add ab plus ab, I'm going to get 2ab. 2 ab's plus, and then the last is b times b, b squared. That's the pattern. Now let's say there's a minus version. A minus b squared equals, you'll notice I'm kind of dropping the keep change now just because I think at this point you should be able to go back and forth between plus negatives and minuses. For me, the minus, the subtraction sign is a little bit easier when it comes to factoring. I think when you FOIL, it's still kind of, it helps to do plus negative, but you'll see me not doing keep change a lot in factoring. So I want you to recognize that a minus is the same as a plus negative. Now, a minus b squared is the same as a minus b times itself, right? A minus b. Now, if I were to FOIL that, I get a squared minus ab minus ab. That's going to be minus 2ab. And then the last is negative b times negative b, or plus b squared. So these are the two patterns. Now look, well, we'll come back to these, I think. Let's just kind of leave it at that. I'm going to put, so that's the pattern. And if you have, I don't know where mine went. Oh, here it is. If you have a highlighter, highlight that, just because that's the rule. Now let's go back up here and compare the difference of two squares and a perfect square. Factored, the difference of two squares has a plus in one parenthesis and a minus in the other. Perfect square looks like a plus b squared, right? It's this, that means a plus b times a plus b. Both parentheses are exactly the same. Here, the signs are different. So really watch out for that. They kind of look alike. And then unfactored, it's going to be a squared plus 2ab plus b squared, right? This one has only two terms, unfactored, because it's called the difference of two squares for two terms. A perfect square has three terms. Okay, difference of two squares has two terms. Now let's put the minus version here. I'll do that small. A minus b squared, which equals a minus b times itself. Right? And then unfactored, it would be a squared minus 2ab plus b squared. All right, there you go. So that's a comparison of the two methods, and that's the perfect square pattern. Now I think I'm gonna break it right here and then go into the next video.